All right, we are recording. All right, so if we're going to, let's write this out, to find the inverse of a set of ordered pairs, switch x and y. So an example would be, let's say I have set A, and in set A, I have the points 1, 2, 3, 0, 4, negative 1. And I want to find the inverse of this set. Well, first, the way we write an inverse is you take the same variable for the set, so I'm take A, but now you're going to raise it to the negative first power. And then what you're going to do is you're switching the x and y coordinates. What do I mean? So instead of the point 1, 2, we have the point 2, 1. Instead of the point 3, 0, I now have the point 0, 3. Instead of the point 4, negative 1, I have the point negative 1, 4. Now what I want us to do is I want us to find the domain of set A. Well, domain is the x values. So if I'm looking for the domain of set A and I just have a list of points, I'm going to list out all the x coordinates. So we're 1, 3, 4. I also want us to find the range of set A. And if I'm trying to find the range of the set, well, it's going to be all of the y coordinates. So we're 2, 0, negative 1. Now I want us to find the domain of the inverse. The domain of the inverse will be 2, 0, negative 1. And the range of the inverse is going to be 1, 3, 4. Can somebody make a connection between the domain and range of the original and the domain and range of the inverse? Danny?
Domain of A is equal to range of A.
Good. The domain of the original ends up being the range of the inverse, and the range of the original ends up being the domain of the inverse. This is not a coincidence. That's what always happens. When you have a function and you have its inverse, the domain of the original ends up being the range of the inverse, and the range of the original ends up being the domain of the inverse. All right, let's write that out. Domain of original is the range of the inverse and the range of the original is the domain of the inverse. Okay, for my next example, I'm going to make a graph. What is this?
Parabola.
Parabola, good. Okay, before I sketch the inverse, what I want to do is I want to list the domain of h of x. How many people think the domain is just -2, -1, 0, 1, 2? We'll start with the domain. -2, -1, 0, 1, 2. Why not? Why is that not the domain?
Because the graph expands infinitely in both directions.
Good, because this is not just a set of points anymore. Like in that first example, I just gave you a set of points. So listing out the x-coordinates was actually the domain because it was just a set of points. But now, this is not just a set of points. This is an actual graph. I've shown some of the coordinates on this graph, but are those the only coordinates on this graph? No, there's actually an infinite amount of points on this graph. It's because of the arrows. And between every 2 points, aren't there more points between those points? Right? So we can't just list out the x-coordinates and the y-coordinates. So we have to actually look at the graph. The domain is x left to right. So you tell me, what is my domain here? What's our domain? Furthest left to furthest right. Bridget? All real numbers, you got it. You can write all real numbers. I'm going to say the infinities. So negative infinity to positive infinity. Can somebody tell me what's the range? Bottom to top. That's the range. Bottom to top. Lowest point to highest point. Tejas?
Greater than or equal to 0.
You got it. I'm going to write it in interval notation, so bracket 0 to infinity. But greater than or equal to 0 is absolutely perfect too. All real numbers for the domain is absolutely perfect also. All right, so now what I want to do is I want to find the inverse of h of x. To help me out, I'm going to list all of my h of x points. So we have -2, 4. Write it in green. Go back to green. All right, so we have h of x. I'm going to list out some of the points. So we have -2, 4. We have -1, 1. We have 0, 0. We have 1, 1. And we have 2, 4. Those are some of the points. So when I go to find the inverse of this, what I want to do is I want to take those points and I want to switch my x and y coordinates. So we're 4, -2, 1, -1, the 0, 0 stays, the 1, 1 stays, and then lastly 4, 2. And now I'm going to go and I'm going to plot these points. So we're 4, -2. And then we're 1, -1. We are 0, 0. We are 1, 1. And 4, +2. So my graph looks something like this. All right, let's list out the domain of the inverse. Let's write it. So you're looking at my pink graph. The inverse is the pink one. What is the domain of my pink graph?
0.
Good. My domain is 0 to infinity. What about my range of my inverse? Philip? The range?
The range? Oh, sorry. For the graph?
For the pink graph.
Oh, it's all real numbers.
Good. It's all real numbers. I'm going to do my infinities. So go back. Is the domain of the original the range of the inverse? And the range of the original the domain of the inverse? Is that a coincidence? No, it has to be that. It must be that. All right, now let's look a little bit closer. If I have my original graph, which is the green, and then I have my inverse, which is the pink graph, to get from the green to the pink, it's actually a reflection over something. Does anybody know what this is a reflection over? No? Philip?
Reflection over the x-axis?
No, a reflection over the x-axis would just take this parabola and make it frowning. It's like folding it over, so it would just be like a frowning one. It's a transformation just means like you're changing something, but I'm saying it's a reflection. The transformation that I'm talking about is a reflection, but it's a reflection over something. Layla?
Y over x, or y equals x?
You got it. This is a reflection over the line y equals x. The line y equals x has a y-intercept of 0. It has a slope of 1 over 1. So I'm sketching this in the blue line right now. Do you guys see that? If you were to take that green parabola and you were to fold it over that blue line y equals x, you would end up getting the pink graph. This is not a coincidence. Actually, all inverses are the reflection over y equals x. Every inverse is a reflection over the line y equals x. So let's write that out. The inverse of a function is the original graph reflected over the line y equals x. Yes.
What is the quote when it like reflects over? Would it ever like reflect over a line that's like -1, 1?
-1 over -1? Like as the slope? Isn't that just
like the other way?
Oh, then y equals -x?
Yeah, sure.
Yeah. Nope. It's always just y equals x. It's always just a reflection over the positive line, y equals x. Okay, guys, question for you. Going back, my original is the green, the inverse is the pink. For the green, is it a function and how do you know? Is the green a function, the original, and how do you know? Tori?
Yes.
Perfect. That's exactly what I wanted to hear. The original function, the original graph or parabola is a function. It is a function because it passes the vertical line test. What does the vertical line test tell us? It tells us if I sit there and I draw vertical lines, those vertical lines will touch my graph in exactly one spot, right? It cannot touch it more than once. Okay, now let's look at my inverse. Is the inverse a function, yes or no? No, because it fails the vertical line test. What does this tell us? The inverse of a function does not have to be a function. So you could start out with a function and its inverse does not necessarily have to be a function. Can it be a function? Sure. Does it have to be? No. All right, let's keep going. The next part, to find the equation of the inverse algebraically. Step 1, we're going to find domain and range of the original. Then we will find the domain and range of the inverse. Third step, we're going to replace f of x with y. Then you're going to switch x and y. We will then solve for y. And lastly, replace y with the inverse notation. Philip?
If we could do, can we do steps 3 through 6 without actually doing 1 and 2?
Yes. Steps 3 through 6 has nothing to do with steps 1 and 2, but steps 1 and 2 are crucial in our final answer. And not in the first problem, but in the second problem, you'll see why.
Can you go off?
Okay, we're also going to just make a special note, which we discussed but did not write down. Not all inverses are functions. All right, I'm going to do my first example, which is going to be pretty simple. Find the inverse of f of x. And here I will tell you f of x is equal to 3x plus 5. What kind of equation is this on a graph? What would this look like? a line. This is a linear equation. This is an equation of a line. Because this is a linear equation, what's the domain? All real numbers. You got it. Because it's a line, our domain is all real numbers. Because it's a line, what is my range? Also, all real numbers. I wrote the infinities. Uh-oh, I did stop writing. This is a pretty simple one. Since my domain of the original is all real numbers, and the range of the original is all real numbers, my domain of the inverse will be all reals, and the range of the inverse will also be all reals. This is part of our answer. The domain and range are part of our answer. Now we're actually going to find the inverse. So I'm going to go back to my equation. I'm going to, instead of f of x, I'm going to write y equals 3x plus 5. The next step is switch x and y. So I'm going to have x is equal to 3y plus 5. After you switch x and y, what you want to do now is you want to solve for y. How do we solve for y? We need to completely isolate it, meaning everything else gets moved to the other side. So the first thing I'm going to do is subtract that 5. So x minus 5 equals 3y. And then lastly, I'm going to divide by 3 on both sides. So I get y is equal to x minus 5 over 3. Very last step is replace that y with the inverse notation. And our answer is going to be this function with a domain of the infinities and a range with the infinities. Do you guys agree this is also a line? Yeah, you might not be used to seeing it like this. You might be used to seeing it as like 1/3 x minus 5/3. But these are exactly the same thing. 1/3 x minus 5/3 is the same as x minus 5 over 3. So since this is a line, does my domain and range make sense? Yeah, absolutely. Okay, so let's see one where the domain and range have a much bigger effect on the problem. So I want us to find, find the equation of the inverse and sketch the original and inverse. Yes?
If it doesn't ask us for domain and range, why are we calling it?
You'll see in this problem why it's so important. All right, let's look at the first one. So, or number 2, I should say. F of x is equal to the root of x plus 3. What is this? What does it look like if we graph it? It's a shooting star. Absolutely, this is a shooting star. So, because I've gotten a lot of questions now, why is the domain and range important? I'm actually not going to find the domain and range. All right, let's not, even though the first thing you should do is find the domain and range. But let's just play into all the questions. Let's not find the domain and range. And let's just find the inverse. So if we're going to find the inverse, we're going to have y is equal to the root of x plus 3. Then it says switch x and y. So I'm going to have x is equal to the root of y plus 3. Now we need to solve for y. In order to solve for y, I need to isolate it. So I'm going to square both sides, and I get x squared equals y plus 3, and then subtract that 3. So I end up with y is equal to x squared minus 3. Replace it with the inverse notation. So my original, what did we say the original was? A shooting star, right? What's this inverse? A parabola. But isn't the inverse just a reflection over a line? Does it ever change its shape? No. So how can the original and the inverse, one be a shooting star and one be a parabola? That's not right. That shouldn't be right. Does that mean we did something wrong? No, the domain is going to alter how this parabola looks. So now let's go back and find the domain and range. What do I mean? So let's go back and find the domain of f of x. Is the domain restricted here? Yeah, how do we know the domain's restricted? Because of what? How do I know the domain's restricted? Tori? Because of the radical. So we know x plus 3 has to be greater than or equal to 0. So x is greater than or equal to 0. So the domain of my original is going to be 0 to infinity. And now to find the range, you might want to just do a quick sketch if you can't visualize it in your head. Oh, sorry. Why did I say 0? -3. Sorry. X is greater than -3. All right. Now, if you could visualize what the shooting star looks like, you don't have to sketch. But let's say you're having trouble. You just do a quick sketch. Okay, so we know we are shifting 3 units. This is a shooting star. We're shifting from our parent graph 3 units in which direction? 3 units, not to the right, because remember, it's supposed to be the root of x minus h plus k. So 3 units to the left. I'm going to write it down here. There we go. I'll do it over here where I have more room. So we're 3 units to the left. And then which way is my shooting star going, and how do you know? Is it shooting to the left or is it shooting to the right? Layla?
To the left because it can't cross the y-axis.
Why can't it cross the y-axis? Never mind. James?
It's going right because it's positive infinity.
Good. It's going right because our domain is saying we're starting at -3 and then we're going to positive infinity. Yeah. I think you're hyping him up a little too much. All right. So then we're starting at -3 and we're going to positive infinity. So this is just a generalized sketch. This is what it sort of looks like. So based on this, what is my range? Michael? 0 to infinity. You got it. So with that said, now let's go down. What is the domain of my inverse? Philip? you got it. So we're 0 to infinity. And the range of my inverse will be -3 to infinity. Okay, now I'm actually going to graph both of these on the same graph. The first one we have is the shooting star, where it was y equals the root of x plus 3. I want us to find the x-intercept. For the x-intercept, we let y equal 0, so 0 equals the root of x plus 3. Square both sides, we have 0 equals x plus 3, so x will equal -3. Then I want us to find the y-intercept. So for the y-intercept, we let x equal 0. So y equals the root of 3. Does anybody remember how to estimate that? Danny?
Like, go to the nearest roots.
Perfect. We go to the nearest perfect square roots. So square root of 1 is 1, square root of 4 is 2. Do we agree 3 is between 1 and root 1 and root 4, but closer to root 4? So I'm going to say about 1.8. It's just an estimate, not completely accurate. So 1.8 I'll say is right over here. So this looks something like that. Now I'm going to graph the inverse. The inverse function was x squared plus 3. Let's find our x-intercept. Our x-intercept will be 0 equals x squared plus 3. Subtract that 3. Will there be an x-intercept?
Wasn't there like -1 x squared minus 3?
Oh, was it -3? It was, oh, so I wrote it wrong, sorry. X squared minus 3. So will there be an x-intercept this time? Yes. So then we're going to have over here 0 equals x squared minus 3. So we're 3 equals x squared, root both sides. X will equal the root of 3. Well, didn't we estimate this as 1.8 before? So we'll use it again. So now we're about 1.8, which is right over here. And now we check for the y-intercept. And we're going to have y equals 0 squared minus 3, so y will equal -3. Oh, this should have been plus or minus root 3. Sorry, there would have been another one over here. Okay, but don't connect anything yet. We are restricted. What are we restricted with? Our domain. Our domain is 0 to infinity, and our range is -3 to infinity. If my domain is 0 to infinity, which of these points, if any, would I have to erase if my domain is starting at 0 and going to infinity? So.
And then the negative root 3.
Good. The negative root 3 gets erased. Right. And then my range is saying it's starting at -3. Is that okay? Is that okay? Absolutely. So what's happening here? We are going up. So what does this end up looking like? A shooting star. Why does this end up looking like a shooting star? Because of the restricted domain. Do we now see why the domain is so important? That is why.
That's wild.
All right, should we stop here? All right, we will stop here.